Okay, Renee, thank you again for the opportunity today. And what we're going to do now is we're going to make a brief video. Again, we're going to show you how the valve operates. I'm going to try to give you as much detail in regards to that as possible. So here's our test bench. And you see we have two waterline simulators set up. The one on the left has our valve already installed. There you see the valve right there. That's a 1-inch commercial valve. You see it's installed close to the water meter on the property side. Very important. The closer to the water meter the installation, the better the performance of the valve. We do not have a valve installed on the line simulator to the right. And you're going to see in a minute, once I start up the test bench, the stark contrast between the line with the valve and the line that's without the valve. And again, keep in mind, once our valve begins to work, it's going to create a compression zone of up to 200 feet. That's going to go past this water meter on down, upstream. It's going to compress the air. It's going to compress the turbulence within the lines. And you're going to see that firsthand. So what I'm going to do now is I'm actually going to start the test bench and explain from there. So right now you're hearing that noise. That noise is the air in the lines. And now the valve is beginning to work and is beginning to stabilize all of the air and all of the volume that's within the line. So let's take a look at the waterline simulation first on the left. And again, this is the line that has the valve already installed onto it. If you notice the water line, you notice the absence of any bubbles, of any turbulence. And that's because, again, the valve is working up to 200 feet and compressing all of that air and compressing all of that volume before it physically is getting to the water line. Now, if we take a look briefly to the waterline simulator on the right, we notice the amount of turbulence, the amount of bubbles that are flowing through this line. Again, beginning on delivery, it's passing through the water meter, and ultimately it's ending up on the end user's side of the property. Let's focus on the water meters themselves, because this is the biggest telltale sign. Again, look at the water meter on the left, the one with the valve installed, and the water meter on the right without the valve. Notice the difference in regards to the quickness of the revolutions of the meter. See how much slower the meter with the valve is functioning as opposed to the meter that doesn't have the valve. Again, this is because of all the turbulence that's coming through the meter and hitting it. And our valve is once again creating an action which is minimizing it. Very important, Renee, to focus again on the differential between the two lines and between how much more pressure is in this line and the absence of all that on this line. We're using a portable pumping system at around 40 to 45 psi. So just imagine an additional 20 to 25 psi being delivered, which is standard psi in most residences and most commercial facilities. And imagine how much more air would be going through these lines and how much more bubbles and turbulence would be present. If you have any more questions, please feel free to ask, and hopefully we've been able to explain a little bit better the technology of how the valve works.